Hello friends, and welcome to a lecture on computational numerical methods. Today we will look into Taylor series and truncation errors. I am Professor Arvind Prasad. For a single variable, the Taylor series expansion is given on your screen. That would be fx is equal to f a plus x minus a 1 factorial multiplied by the first differential of the function at a plus x minus a the whole square by 2 factorial multiplied by the second differential of the function at a plus x minus a cube divided by 3 factorial multiplied by the third differential of the function at a, and so on. Now, this is the expansion of Taylor series of the function at a point a. This is a very elegant way of expressing a non-polynomial function as a sum of polynomials. Now, this is the beauty of Taylor series. Now, let's look into what would be the truncation errors if we used Taylor series. Let's assume we have to expand the function e raised to x around x is equal to 0. Therefore, we get e raised to x as this, e raised to 0 plus x minus 0 over 1 factorial, e raised to 0, x minus 0 square over 2 factorial, e raised to 0 plus x minus 3, x minus 0, the whole cube by 3 factorial, e raised to 0, and so on. So the expansion will result in this expression. Now, if we take it to the first 5 terms, it would look like this. 1 plus x square by 2 plus x cube by 6 plus x raised to 4 by 24. Mind you, this is 2 factorial, this is 3 factorial, this is 4 factorial, 5 factorial, 6 factorial. And this is x raised to 6, x raised to 5. Now, let's estimate e raised to 1. So, for x is equal to 1, we have this as the series. Now, this gives you a value of 2.71665, which is very, very close to 2.7188, which we have found using the calculator. So, now let's have a look at what would be the truncation errors. It is best if we look at what is truncation errors using a spreadsheet. The idea would be a bit more clearer if we would actually speak about it rather than we calculate it on the spreadsheet and demonstrate what are truncation errors. So this is the spreadsheet or where we can study the truncation errors. So let's write the terms first. 1, 2, 3, 4, 5. So in the first term we have 1, in the second term we have 1 over 1 factorial. So let us calculate the factorials. Of these numbers. Now the terms are, the first term is nothing but 1 divided by 1 factorial. 1 divided by 1 factorial. That's it. And similarly, we calculate all the terms. Now, the final value of the function is equal to 1 plus the sum of all the terms. So these are all our terms. So there we have. If we take the sum of all the terms and add 1 to it, we get the estimate as per the equation that we have just given or just derived for calculating exponential of x. Now, what if we calculated the value of the exponential only using the first term, how much would it be its value? So it would be 1 plus the first term. Now what if we calculated the value using the first two terms? So it would be the previous term plus the second term. And let's do it. This would be the value for the third term, and this would be the value for the fourth term. Now the truncation error is going to be equal to the value that we have minus, that is the value that we have calculated using the entire expression with 5 terms, minus the value we calculate using the term. So this is the value, or this is the truncation error that we are going to have in case a slight mistake here. Yes, this is the value of the function. Yeah, so this is the truncation error we are going to have in case we take only one term, and this is the truncation error in case we take two terms. Now this is going to be the truncation error in case we take 3 terms. So what is this exactly? This is nothing but the value that we have calculated using the expression minus the value we have calculated using only the first 3 terms. Now the difference of this and this is nothing but the truncation error. Now what does truncation mean? Truncation means neglecting higher terms. Now let's take an example. We have an expression in which we have 10 terms. If we say it has been truncated, okay, from the 6th term, it means 6, 7, 8, 9, 10 terms, 6, 7, 8, 9, 10 have been neglected. If we say we have truncated from the 3rd term, then we say from the 3rd term to the 10th term, all the terms have been neglected. Now here too, as we can see here, the truncation error arises from calculating the value of exponential using only first 3 terms and then calculating it with the expression that we have taken. That is, it was for 5 terms and it gave a fairly accurate value which was very close to that we have done in the calculator. So this is all about truncation error. So this is the truncation error we get using first 4 terms. So hope you have understood what is truncation error, and do like and subscribe my channel. Keep watching. There will be more such interesting videos. Goodbye.